Welcome to the Walton Pie. Today we're going to be talking about series. Now, before we get started, if you are enjoying these videos and they're helpful, please consider subscribing because it really helps me out to be able to make more of these. So, without further ado, let's start talking about series. So first off, what's a series? Well, if we have a sequence of terms, so this is what we talked about in the last video where we have like AN is the sequence of terms A1, then A2, then A3. If we were to add all of these up, that's what we call a series. So if there are infinitely many terms that we add up, then that's what's called an infinite series. So a series is really just adding up the terms of a sequence. So when we're adding up several terms, we can use what we call summation notation or sometimes sigma notation. Because this big weird letter E, that's a Greek letter called sigma. And so we are going to be using this to represent a sum. Now, if we see something like this, let's break down what these different pieces mean so that we know what we are referring to when we are talking about a sum. So the variable that is set equal to a constant beneath the fancy e, so the sigma letter, that's what's called the indexing variable. So that's this k down here. Notice that the k also shows up in the a sub k after the sum. So this is saying what are we adding up? And we are indexing it by saying that we are starting at a certain value and going to some other values. Now, those different values that we are setting the indexing variable equal to, well, the first variable is k equals 1. That's the first value that we replace the variable with. And then we are going to continue to increase that value until we have reached the value on top of the sigma. So k equals 1 says that the first thing we add up is the a sub 1. And then we are just going to keep adding up terms until eventually we reach n. So we're going to go a1 plus a2 plus a3 plus a4 plus a5 until we've reached the a sub n, that is our stopping value. So the one on the top is where we stop, the one on the bottom is where we start. This is very similar to the integrals that we see, where we have the integral from a to b. You start at a and you stop at b. It's the same thing here with these sums. So let's go through two examples together. This will help us be able to formalize and make the connection in our heads to be able to see what we're doing. So let's write out the series, the sum from j equals 1 to 10 of 4j plus 3. Well, we are going to start with j equals 7. So that's going to be 4 times 7 plus 3. And the j is not yet 10, so we're going to add the next term. So plus 4 times 8 plus 3. 8's still not 10, so we're going to add another term. 4 times 9 plus 3. Well, 9 is still not 10, so we're going to add another term. Plus 4 times 10 plus 3. So we are going to have added up all of these terms, and we stop at this one because 10 is the value that we were told to stop with. We can then evaluate this by solving for what each of those numbers are. So 4 times 7 plus 3, that's 31, then 35, 39, and 43. And if we add all of those up, we get 148. So this series is equal to 148. Let's go through one more example. Write out the series, the sum from L equals negative 3 to 4 of 1 over L squared plus 1. Well, we start out with this, and we start with the first term. So we are going to start when L is negative 3. That's 1 over negative 3 squared plus 1, but negative 3 is not yet 4, so we add the next term. So increase negative 3 by 1, we get negative 2. Then we add the negative 1th term, the 0th term, the 1th term, or the first, but it's not the first one, so I'm going to call it the 1th term, the 2th or 2nd term, and the 3rd term, and then the 4th term. And this is where we stop, because 4 is the number to stop at. So if we add up all of these, well, 1 over negative 3 plus 1, that's 1 over 10. Then we have 1 over 5. So we can figure out what all of these are, and then that equals 2.64. So that's the value of this sum. I hope this video is helpful in understanding sums. Feel free to check out some of my other videos, and if these are helpful, please subscribe. It really helps me to be able to continue to make these videos. I hope you have a great rest of your day, and good luck with all of your math.